हरिकन्ना
Welcome to the third part of Module 5, that is Automate with Jenkins. So, in this part, we are going to discuss about why we require an automation tool. So, why can't we do without an automation tool? And we will discuss all the features that are offered by the Jenkins, and we will do the installation. Then we will check freestyle, what's freestyle and what is pass pipeline as a code, and we'll see how to install tools inside the Jenkins. We'll see how to configure the plugins and how to install plugins inside the Jenkins and how to build the first job. And we will also see plugins and versioning, and we'll see a flow of continuous integration, and we will build a continuous integration pipeline, a continuous integration pipeline with Docker, a continuous integration and continuous delivery pipeline, and continuous integration and continuous delivery pipeline with Docker. So let's begin with merging. We should really understand what is a continuous integration and what problem does it solve. So developers, when they are working on a product development or a code, so they will write the source code, they'll develop a source code, and then they will build the code and they test it. They test that code locally in their local machine, and finally then they push it to the centralized version control system. So this is what the normal process. We have been discussing this flow. We have been discussing this pattern almost for more than 15 to 20 times so far. Even in Maven we have discussed, even in our Git we have discussed about this information. Okay, so writing the source code, then build it and test locally and push it to the remote repository, that is our uh, centralized centralized version control system. And this is a continuous process. So write the code, build the code, and test it locally. If everything is good, then push it to the centralized version control system. This is a continuous process. This will be done by the developer 1 that you see on left side. He's developer 1. The same will be repeated by developer 2, and he will push it to the version control system, centralized version control system. In this example, it is GitHub. So then again, the second developer comes into the picture, write the source code, build the source code, test it locally, and push it to the GitHub. Same, the third one. This cycle repeats and repeats. So like that, all developers will be doing the same thing in a team. So now obviously that sounds good, but then there is a problem with it. What is that problem? Can you get it? Can you understand? Can you tell me what is the problem? If you know, just ping the problem in comment section. I'm gonna look into that. So what is the problem? So of course there is a problem, and that's why we are going to use a continuous integration to solve that. So the problem, well, this is happening many, many times in a day by all the different developers, and the codes or the code gets merged into the centralized repository on a regular basis, and days passed, weeks passed, sometimes even months pass, the code keep getting merged, and then after some time, if the code is together built and tested, it generates a lot of bugs, issues and conflicts. So that's happening because the code is getting much, but really not getting integrated. The code is getting merged, the code is getting merged, but the code is not the code is not really getting integrated. So as the days passed, week passed, sometimes even months pass, the code is keep on getting merged and merged and merged, but it's never getting integrated. So because of that, after some time when you want to test it, it generates a lot of bugs, lot of issues and lot of conflicts. So as a developer keep merging the code to the version control system multiple times in a day and several times in a week, and there could be so many bugs. So will this code is getting merged, and after a long time when it is tested together, it generates those errors, those bugs, those conflicts, and that's very natural. But the problem starts after that. What's that? After this, everything needs to be fixed. That's where the pain comes. That's where the resources will be lost. That's where your capital will be lost. That's where your client will lose the faith on you. So the main problem starts after that. That is, everything needs to be fixed. All bugs, all issues, all conflicts to be fixed. So developer developer needs to do a lot of work, invest a lot of time in fixing all this, and maybe the deadline is already coming close, or maybe you're already past the deadline. So now what's the solution? What can we do? So the solution is continuous integration. Though the integration is a painful process, though integration is a painful process, but still I say the solution for this is continuous integration. But nevertheless, it has to be done. But if we don't come to this problem, what if these bugs, these errors, these conflicts get resolved as regular as the code is getting merged? Yes, what if what if these bugs these errors, these conflicts gets resolved as a regular basis as the code is getting merged. Every time when you push the code, if it resolves the bugs and other errors and conflicts on a regular basis, how would it be? So for that we have a solution. For that there is a solution. So whenever there is a code change in a centralized repository, or or for every commit, for every commit that is done by the developer or by any developer, for any commit which is done by the developer or any developer, we build the code and build code for every commit, build and test, of course. And if this has to be done for every commit, then this process needs to be automated. Whenever there is a code change, the code should be fetched, built and tested. If there is anything wrong, the developer gets notified, and then developers can pitch in and fix the code. This process is called continuous integration. Code is written by a developer, code is built, then code was tested locally, then code has been pushed into version control system, centralized version control system, that is GitHub. So once it's pushed to the centralized version control system, so now an automation tool should come into the picture, and it has to do following activities. So here let's take one example. So this developer has written a source code, built the source code, tested it locally and pushed it to version control system. So that's GitHub. So now an automation tool should come into the picture. As soon as the commit has been done by the developer, the automation tool has to fetch the code from the VCS or GitHub version control system or a remote repository. From that it has to fetch the source code, then build the source code and test the source code. If there are any issues, any bugs or any conflicts, it has to notify the developer back, and this cycle is gonna repeat like a circle. So fetch, build, test, deploy. So this cycle is gonna continue. Whenever you commit a small piece of module into VCS, the cycle is going to be repeated. This is going to be repeated again and again. For each and every commit, the cycle is to be repeated, and this is called continuous integration. This is called continuous, this process is called continuous integration. So when developer makes the code change, the code should be first built, tested and notified to the developer, and if there is any failure, the developer will get a notification. Developers will stop doing whatever they are doing, first fix the problem first, and then continue their process. So because of this, if there is any problem in the code, it will be caught immediately and fixed also immediately. So we will not be waiting for a longer time and accumulate all those issues, bugs, conflicts. So or they even gets multiplied so many times, and this is the continuous integration process. In short, so in short, so not only just merging the code, but also for every commit which will test and notify. So as I said, if this is a continuous process, then we need to automate this process. So if you automate this process will be called a continuous integration process, and Jenkins is the most famous tool for continuous integration. So it started as continuous integration tool. The Jenkins started as a continuous integration tool anyways, but now it's much more than just a continuous integration. It's a continuous integration, continuous delivery, continuous deployment. For Docker also, for Kubernetes also you can use it. It's much more, it's much bigger than what they have imagined. But a very basic use case of Jenkins is the same. So whenever there is a code change by the developer, Jenkins is going to fetch the code, build, evaluate it, and notify the developer. So this is a continuous integration process done by Jenkins. So Jenkins has many features. We can just keep talking about it, but I think it's too many, too many features are there. So it's open source, and so there are too many features it has. But out of which we are gonna talk about two main features. Two main features out of which one is it is open source, and second one is it is extensible. So it can have many features. Developers around the world are contributing to the Jenkins source code and making it a better every day. And as I said, now Jenkins is not just a continuous integration server. It's much more than that. It's much bigger than that. There are so many plugins that gets developed for Jenkins. For example, plugin for version control system to integrate Jenkins with almost every version control system. So build plugin, so you can build a Java, .NET, Node.js, any kind of source code by their build tools. So cloud plugin, testing plugin, in and really many plugins are there on Jenkins that gets every day developed, and they keep on, the Jenkins open source community keeps on developing these new plugins. So because of its open source nature, it is extensible, and because of its extensibility, it is popular and it is widely used. And I really enjoy working on Jenkins, and I have around 6 years of experience of working in Jenkins automation tool.